So we are going to start the session shortly in a minute. So I hope our voices are audible to all. And as you know that today is our last session of this week program. So officially we can begin the session with a bit of introduction. So first of all, good evening everyone. I welcome everyone to this today's validatory session as today is the end of this session. Being a founder of InnovaWorld Research Center, InnovaWorld Private Limited, it gives me immense pleasure to welcome you to this week skill development program and faculty development program on artificial intelligence and machine learning in industrial engineering, organized by InnovaWorld Research Center of InnovaWorld Private Limited from November 4 to November 12, 2024. This program marks a significant steps towards equipping professional and enthusiasts with advanced tools needed to transform industries, solve complex challenges, and pushes the boundary of innovation. So today, as we have our special guest, welcome our Dr. Majumder, Research Head in our World Research Center. We'll be enlightened, and he will be enlightening us with his applications of AI in ML and also hands-on practice session using some tools and that how to work on those AI and ML. So, sir, once again, I welcome you to this session and let's make this session one to remember. Over to you, sir.
Okay, thank you very much for the introduction. Actually, already I have given three lecture session here about the AI and ML, and I also have given some hands-on practice sessions for some AI algorithms. Which one? First one is linear regression, and also the non-linear regression we have practiced in the last two sessions. And also I have implemented the algorithms in MATLAB. So today I will go for some classification problem and one classification algorithm. I will also give you an example and some hands-on practice in MATLAB also I will provide. So before starting that, as in the last session, I have introduced about the that means nonlinear programming. Sorry, nonlinear regression. So another example of nonlinear regression in MATLAB, I will also provide today. So for this one, first let me discuss about the data set. Please confirm that whether my screen is visible or not. Is my screen visible to all of you? Okay. So let me go to this data set first. First of all, this is a data set of wind turbine. So this the data set, actually I have opened this data set in MATLAB. So basically it is an Excel data, and I have imported the Excel data in MATLAB software. So that is why it is now visible like this. So there are, you can see the columns are A to H. These are the columns, and the first column name is DD. It is the actually means a diameter. Okay, HD, it is the height of the darius. Actually, the dataset name is darius. Darius is one kind of wind turbine. So it is the diameter of the radius. HD, it means the height of the radius, and it is solidity. TSR chord, V is for velocity, then it is the number of blades, and CP it actually the power coefficient. So the coefficient of power, it is the outcome here, CP, and rest of the other variables, that is DD to N. All these variables are independent design variables, and CP is the dependent variable here. So if we see the values of CP, so these values of CP are basically numerical, and there is no we cannot say that there is any particular category assigned with CP. So it means that either it is neither yes no format, nor it is looking like some category. It is giving us some floating point values, and also it is easily we can say that this is the continuous value. So of course, since our outcome variable CP is taking the continuous values, so we can say that it is a we should go for the regression to estimate the data, or to form a model. So there are many models. As I told earlier, that is, we can make the model by using ANN, by using means some other cases means linear regression. Okay, non-linear regression. So as linear regression we already discussed. So this model, now I will form a model by using non-linear regression. So let me go to the board first. So before starting, as we know that linear regression means we have to form a linear equation. That is the here CP is the power coefficient, is the output variable. So this is the output, and we need to form. Let me count the number of design variables here. One, two, three, four, five, six, seven. Seven design variables are there. That is, these are the independent variables. So it means that our equation, in case of linear model or linear regression model, it should be like this: a0 plus a1 into x1, a2 x2 plus up to a 8, a8, and sorry, a7, a7 x7. Since seven decision variables are there, or sorry, design variables are there, so I have taken uh, dd as x1, hd as x2, solidity as x3, and so on. Okay, so it means our equation will be formed like this. And by using linear regression, we need to identify, or we need to find out the values of a0, a1, a2 up to a7. Then we will create some model, that is CP is equal to, after applying the linear regression model, means in MATLAB. uh, So let us suppose it is 1.1 plus 0.2 into x1 plus 0.02 into x2 plus like this dot. Okay, so this kind of model. Okay, I don't know what is the actual value of a0, a1, and a2. Just for the sake of example, I am just forming this equation. Okay, now if we pass any value of x1, x2, any set of values of x1, x2, x3, and up to x7, it will give you a predicted value of CP. Okay, now in case of, as I earlier I told you, in case of nonlinear regression, nonlinear regression, you can use different types of nonlinear equations. Okay, it may be polynomial with degree 2, it may be polynomial of degree 3, it may be logarithmic, it may be some exponential or some other kinds of, or maybe inverse function. Okay, so since the last class we have I have already shown you the uh, example of polynomial of degree 2. So today I will show you a logarithmic type of function. Let us suppose I am considering a nonlinear function with the design variable x1 to x7 like this. Cp is equal to, let us suppose it is a naught plus a1 log x1 plus up to a7 log x7, right? So we have to form the equation like this. Okay. Now, what we need to calculate here? We need to calculate the values of A0, A1, A2 up to A7. Means A3, A4, A5, A6, and A7. All these values we need to calculate here. So ultimately, after calculating, we can form a equation like this. Cp is equal to, let us suppose, 2.2 plus 0.17 log x1 plus 0.002 log x2 and so on. So this kind of equation we can get. Okay, now any set of values for x1, x2 up to x7 we can get, we can predict, we can a predicted value of cp we can get. Okay, so let us implement this function, let us develop this particular program in MATLAB now. So this is my, I already have means, okay, first of all, before starting that, since in the previous session I didn't means say that how to means load a data in MATLAB. Okay, first of all, after installing MATLAB, let me show you a folder will be created in documents folder in your computer. The name folder is named MATLAB. So just after installing MATLAB in your computer, you can just go to documents. So let me show you. So documents, here it is a it is opening now. So just click on the documents and you can see automatically a MATLAB named folder will be created here. Now, whatever the data set you want to use, you have an Excel data set, let us suppose. So first you need to copy and paste that particular Excel file here in this MATLAB folder. So whatever these are the different programs and different you can see the data sets I have pasted here. So this is the DDS data set which I have already pasted here previously to give you this example. Okay, so I have copied and pasted. So next, when you go to MATLAB, so you can see after copied after pasting the data in MATLAB folder, automatically it will be shown here. You can see here. Okay, and every data set you can see I have stored different data sets, Excel data sets here, Excel or XLSS or whatever the CSV file also it can take. So you can copy and paste here. After copied and pasted, you just click on this data set and you can double click on it and the Excel format in MATLAB it will be opened. Now just simply whatever the data you need. Okay, let us suppose just for the sake of, let me first clear the memory. Okay, and also percentage symbol is just to nullify the commands. Okay, if you use the percentage symbol, all these commands will be nullified. Okay, just as a command line sentence you can use it is. So now I am just making a new program here, and by using that data set. Okay, so I am double clicking on various data. And let us suppose instead of using all the design variables, I am going to use only three design variables. Let us suppose the first one is dd. Okay, I've selected this one. Second one is hd. Okay, just by clicking on the by pressing the control key, you can select as many as row, whatever according to your choice as possible. So third one is, let us suppose TSR and the CP. Okay, so these are the four data sets, four columns which I need to select. Or remember that in MATLAB, while using the nonlinear regression, okay, always you need to keep the dependent variable. It means the outcome variable, since it is CP here, at the last position. Okay, and you need to select table here in the table form. There are different formats here to import the data in MATLAB. First one is column vector. That is, each and every column will be separately stored in MATLAB. Second one is matrix. As a row and column format, it will be stored in MATLAB. Third one is a cell array. Okay, each and every row will be selected as a cell. And fourth one is table format. It will create a table like this. So while using the nonlinear program in MATLAB, the command which I am going to use here, it takes the tabular format. So select the table. So automate, and simply you can click here. Now a table will be created here. You can see this in workspace. The table 22 cross 4 table. It means that this is four columns and 22 rows are there. And this is the Darius dataset. Now, if you want to show this dataset in MATLAB command window, okay, you can simply type here Darius. Just let me copy here. Simply you can type here Darius, and you can see that how these four columns are stored in MATLAB in tabular form. Okay, now I need to create a variable. Let us suppose this first variable table. So capital T I am using here. T is equal to it is already formed so T equal to Darius. Since it is already we have stored the dataset in tabular form, so no need to use the table here, table command here. Since in the previous program, the horsepower, weight, and MPG, this here we have stored as a column vector format. That is, each and every column are separately stored in MATLAB. So that is why we have used the table command to form the table. But since we have already imported the data as a table format, so no need to use table command. Next one, now the creation of the model. Okay, so I told you that the model should be logarithmic here. So let us create another variable here, which is MDL, and also the same thing, that is b comma x. Okay, so there it is b comma x. B represents the vector for the constants a0, a1, a2. Oh, okay, the constants. And x, it represents the vectors, that is a vector for the data set, that is the data for ddht ts, this one. Okay, so now let me create the function. Now first one, uh, sorry, small b. The first, now go to the, is what is our function. First one is a naught. Okay, so instead of a naught, I am using here b1, because there is some format in MATLAB as we are using the vector. So here b1 we have to use here, because zero index, it is not applicable in MATLAB. So you have to start with indexing as 1. uh, from 1 we have to start. So I am creating b1. So since there are how many independent variables are there, independent variables are dd, hd and tsr. So b1, it represents the constant term. Okay, that is a0. What is a0 here? A0 term, it is represented by b1. So a1 term, it should be represented by a2, sorry, b2 here. So plus b, okay, b2 into, so multiplication, it is we have to use a star here, log. Now here it is important. So now logarithmic function here, you can see nowadays we are using the dd. There is the first one. Okay. So okay, one thing you should notice here, we didn't clean the data set. Okay, the first here you can see NaN, it's already included here. Similarly, last two columns also NaN is included. So basically it is by mistake it is done like this, because directly I have shown the means I have selected the columns by clicking on the top of the column, which was not actually applicable in MATLAB. Okay, basically we need to select properly. I didn't select that one properly, but no issue. MATLAB can easily handle this NaN form without, if the data is not cleaned also, still MATLAB will run this from this data set. So which so that is why without cleaning the data, I'm using this. So let us see what will happen. There you can see the first column, it is totally NaN, that is not a number, and the last two rows also it is taking NaN, not a number. So it means that there is null values are there. Okay, so here now b2 into log x1. X1 means we are talking about the dd, but dd here it is represented as in MATLAB. Automatically the dd, it is created as x1, the first vector for these dd data sets. Okay, so dd, there are how many 2578480, these values are already stored in x1. Okay, so we need to create we need to use like this, colon comma 1. Why? Because sorry, x. Okay, why? Because log x, first one is log x1. So colon means it is represented, the first index is represents it represents row, second index it represents column. So if I use colon, it means that whatever the rows, all the rows are selected, but we are fixing the column as 1. And what is the column 1? It is a dd. So it means it represents all values in dd column only. That is 2578480, 4042 and so on. Similarly, uh, we should proceed with the same thing. Second one is b3. So b3 into log. Okay, so here it is x. Now HD. So HD is the second one. So it means the second column we should select here 2. And the third one is TSR. TSR, of course, it is a third column. So we should write here B4 into log colon, sorry, X. Free. Okay, since it is getting outside, let me. Okay, so so now I think it is created. Okay, last one is CP. No need to create CP here because CP is the dependent one, which we CP actually we are going to estimate the value of CP. So that is why no need to consider CP in this function. Means we should not consider CP in the function, of course. um, Automatically the MATLAB, after going this tabular form, automatically it will create that yes, the CP as in the dependent variable, which it is going to estimate. Okay, so next one, after means creating this function, now this function is created according to our choice. If you want to change the function, you can also change it. Some other non-linearity you can also use here. Okay, if you want to use some logs functions, means log x1 into log x2, multiplication of different log functions, if you want to create that, you can also create. Okay, next one is initialization. Okay, so initialization, let us suppose I, it is I, we need to create this vector. So initialization, what are the values we need to estimate, or we need to find which values we are going to find out here. First of all, b1, second one is b2, third one is b3, and the fourth one is b4. So it means that we need to calculate four values here. b1, which is the constant term, b2, which is the coefficient of log x1, b3 coefficient of log x2, and b4 coefficient of log x3. So for four values we need to initialize four different value here. Just you can consider these values according to your choice, just as an initial guess. So it is means you can also use the values which you want to estimate. Means you can see the data set here. So first data set, the minimum and maximum value of the data set. So accordingly, you can choose any middle value of this. So you can see here 700, 3000, all these values are there. So let us choose the first one. Okay, sorry, the first one is the constant. So let us suppose constant as 0. Second one is, let us suppose it is 700. Third one is B3. B3 means HD. So HD, the look at the values of HD, and we can say that it is highest 24 or 1 lakh something. There is a different values are given. So let us suppose the initialization as 50,000. Then it is TSR. So TSR values you can say here. This is also a lot of variations of the values here. So let us suppose it is 47. It is the maximum. 2000. Initialization is done now. Okay, now we need to means fit the nonlinear model here. So let us create another function here, estimate, est model, estimated model. So estimated model, and as we have told you, that is fit NLM. Fit NLM function we need to use. Fit NLM. And what are the parameters of fit NLM? First one, we need to pass the table. And what is the table name? Capital T. So capital T. Then the function. What is the name of the function? MDL. MDL represents the function. And the third one, initialization, that is I. I. Okay, so our task is done now. So now we need to run this model, and the model is on. Now we need to display the model as now first of all we need to display the model. Okay, the model is represented as est model. Okay, So let us display, just simply go to the command window and you can paste the name of the variable, means which is um, denoted by the model fit NLM. So this is the model now. You can see here, so B1, B2, B3 and B4 values are calculated here. So first one, let us explain this one separately. So let me copy and paste the value first. It's getting slow. Okay, so let me copy from here. Okay, so these are the values. Yes, now it is open. Okay, so now let me discuss about the model. So these are the values, you can see B1, B2, B3 and B4. These values are, so the model is now CP is equal to, it is estimated as CP equal to, first one is B1 is the intercept, that is the constant term. So 0.2685 plus B2 is the first one, so minus 0.007 or whatever dot dot into what is the first variable name? Our first variable name is DD. So first variable name is DD here. That is the Darius, I think this one, okay, right? Yes, first variable name. Let me, yeah. So what is the first variable? So DDS we have created since 3 only 4. So let's go to the DDS here. So it was DD, HD and TSR. So these three values are selected. So it will be like this. DD,
Sir, sorry to interrupt, sir. I think,
yes. Hello, yes.
sir, sorry to interrupt. I think, can we increase the size of your screen, sir? So actually, when we are streaming, it is not clear. So it is suggested that please
Okay,
can you
okay.
enlarge
Is it
it more?
okay now?
Yeah, I hope it will be better. Okay, please continue, sir.
Is it? It's okay.
You can continue, sir. We'll update you, sir. Yeah,
Okay,
better, better, sir.
okay. So DD, and the third coefficient is B3. B3 is this one, that is, it is plus 0.0098, okay, into D DR, radius of the plus TSR, that is the TSR is this one, the coefficient of TSR 0.0595. 503 into TSR. So this is the model. CP is equal to this one. Now for any values of DD, any set of constant, let us suppose if I have for 400, dr is equal to 10. Simply we will pass these three values, these three set of values, 900, 50 and 10 here in this model, and we can easily estimate what is the value of CP. Okay, now the problem is how much acceptable this model is. So as we have already discussed about the metrics of the regression, so first root mean square error. Okay, this one, r squared, this one, adjusted r squared, this, p value, this, and p value of b1, p value of b2, p value of b3, p value of b4. First of all, for r squared value, it is not at all a good value, because r squared value, I told you that it should be near equal to 1. More than 0. 0.8 or 0.9 should be a very good model, but 0.04 is not at all, it is giving us a good model here. Okay, next one is uh, p value. P value, it should be less than or equal 0.05, which is also very high here. 0.1, 0.8, 0.8, 0.4, not at all near equal to the 0.05. Also here p value, you can see the model p value, the entire model 0.861, also it is not so good. So we can say that whatever the model we have created here, this model will not give us a proper approximation. Okay, so we should not use this model, and we have to go to some other form of the model if we use the nonlinear regression. Otherwise we can go for the linear regression here. Okay, and we can use some different means values, or since we have reduced the number of columns here, just we have for the given an example, for giving an example, I've reduced the number of columns, that is number of independent variables are reduced. So that also have an high effect on the evaluation of this model. So model, of course, it will be affected, and means model will be affected by this if you delete some particular parameters from there. Okay, so again, this is the non-linear model. I think now all the participants have understood that how to create a non-linear model in MATLAB, and what is the mathematics and statistics behind this non-linear model formation in machine learning. So now I will go today a little bit example of, since this model is for regression, both linear and nonlinear regression I have used there, used in the last two sessions and this session also. So today I will give you a touch of classification model. So classification, you need to first choose a data set like that where we can apply the classification model. Okay, and difference between classification and regression, as I told, that if your independent variable, here you can see that independent variable, uh, CP independent variable. So this CP is a continuous data set, so that is why you have to use the regression here. So now let us clear this model. Let's clear the memory, and let us go to another data set. data set is actually large, so that is why it is taking a little bit time. Yes. So now you see this data set. So this data, here you can see it is a large data set, and here this data set, it is a, I think, symptom for paralysis. Yes, it's a medical biomedical data, and this is the outcome variable here, and which says that this is means the outcome. It says that whether a particular person is having is paralyzed or not. Okay, there is a symptom of paralysis. If it is zero, then it is no symptom of paralysis is observed, and if it is one, look at this here somewhere. Yes, it is one here. Okay, so it is one here, one here. So if it is one, then there is a symptom of paralysis you can observe. Okay, and how many independent means values are there? So basically, the last one, pattern 2, it is not used. It was created by me just for another experiment, but it is not for the example. This one, this symptom, this is actually the outcome variable here, and the other one, that is the, what are the independent variables? First one is blood pressure, second one is heart rate, third one is PPG, ECG, physical activities, means how much physical activities. If I think it is a scared value. Zero means no, one means a little bit exercise, two means yes, quite exercise, and three means a very high level of exercise is doing, he or she is doing, the person. So second one is diet, that is nutrition, I think is, yes, and diet and nutrition. So diet and nutrition, it is also a binary data. You can see yes, no. Zero means no and one means yes. So if dietitian, yes, no, it was like that. If it is having any junk food or outside food, then food habit is zero, and one for if it is not having the junk food, then it is one. Then medication, if it is having any medication, then it is one, otherwise it is zero. Sleep pattern, so if it is sleep pattern is good, no sleep disturbance is there, then it is one. Then physical activity, which is the symptom of paralysis. So basically, we are watching the data set, that if your dependent variable, that is symptom of paralysis, is a binary category, so 0 and 1 only, of course we can say that it is a categorical variable or categorical data. Since it is categorical data, we have to go for the classification model, and there are a lot of classification model. One of the very popular classification models are logistic regression, which I want to discuss today. Okay, so basically it is based on it is a probabilistic approach, means, and it uses a sigmoid curve to find out the probability. Okay, so let me discuss about how it works. Mathematical background or statistical background of this class, means logistic regression is like this. Let us suppose the data set is created like this. X1, X2, X3. These three are the independent, and Y. This is the dependent. 1, 1, 3, 2, 3, 4, 5, 3, 2, 0, 0, 1. 0 1 dot dot dot. Just for the sake of example, I'm giving you this data set. Okay, so how logistic regression works? First, we need to find a linear function. Y is equal to a naught plus a1 x1 plus a2 x2 plus a3 x3, just like it is a simple linear form. Okay, linear, but we have to use some other algorithm here, and the method name generally very means most of the cases we use MLE to form this equation, which is the name of which is maximum likelihood estimator. It is a very famous approach in statistics, in estimation theory of point estimation. The maximum likelihood estimator, it is to calculate an statistical estimator, which actually can give you or can provide a picture of to estimate some original value of any kind of parameter like mean or standard deviation or these kind of things. I'm not going to the deep into the statistical view because it was means too much statistics and mathematical equations, and uh, a very complex equation will be formed here. Mathematics, there is calculus is also used here, and estimation theory is also used here. So I'm not going to that one. Just you remember that you need to first find a function like this, a linear function, which is y equal to, just like it is linear regression function, that is a naught plus a1 plus a1 x1 plus a2 x2 and x3, okay, as we have used in the linear regression case. But we use some other things, which is the MLE, maximum likelihood estimate, is used here. Okay, so after predicting y, so y will give you a value. Okay, so this y, we have to use another function here, which is called the sigmoid function. Okay, so sigmoid function, just a moment. It is okay. So again, sorry for the disturbance. Okay, so what it told, yes, sigmoid function. It is looking like this. F of y is equal to, okay. I'm using y here. Means this y here is equal to 1 by 1 plus e raised to the power minus y. So it means whatever the value of y we will be getting, these value will be we will pass through here in this y, and we can get some value here. Let us suppose it is v, and of course this v will be between 0 and 1. Okay, and the value of this means the curve of this fy function, that is sigmoid function, it is
So,
uh, looking, yes.
sir, is there are some queries? Um,
Yeah, yeah.
is it right time to discuss, sir? So
Yeah,
you
yeah,
have
but your
mentioned
voice is
that
very less
your
audible.
okay. Am I audible right now, sir?
Yes, yes.
Yeah. So I think it's relevant to that some conditions that you have taken about CP. There is a question to confirmation about the variable, whether that CP value is independent or dependent. Because you have
CP
somewhere
means the
mentioned
power
about
coefficient which I have created. This one, this CP. CP value means the previous data set. Are you talking about the previous data set? DD and hello.
yes, sir.
Am I audible?
Yeah, yeah. Please, sir.
Is CP, are you talking about there is a previous data set which means now I given to the I was means I shown
Is
to
it a
the
both a different one?
linear regression.
Different conditions, sir? Is both the conditions are different, sir?
Uh, both this CP actually that was different data set, and here I am
Okay,
using
okay,
some
okay.
different data set. The data sets are
Okay,
completely
okay.
different.
I think that might be the confusion. Okay, sir. So you are using different data set, but
Yes,
the
yes,
parameter of CP is same, right? That is what you mean,
exactly.
right?
No, parameters are not also same. Parameters are also different because the previous CP data set it was a continuous data set, where the outcome CP is continuous. The point floating point values are there 0 point something 0 point something, so we that is why we used regression there. But here whatever the data set we are using now, that is a biomedical data set, and this one x1 x2 x3, this is I am creating this data set just for the sake of example. Okay, this is completely, this data set is I have created just to give you an example. Okay, it is not related to any other example which I was given earlier, and what I am using here now in biomedical data set, this one, this is not, this is completely different. I am creating this one.
Okay. I think that clarifies it, I hope. Okay. Fine, sir. Can proceed.
Okay, so it is a sigmoid function. So as we draw the sigmoid curve, it is looking like this exactly. S, just S type curve, and this is the origin 0 point, and the upper portion this one, okay, it is the 1 and this is 0. Basically it will not touch 1, it is just like this. Okay, it is not touch 1, but it was going to the infinity, and exactly it will be touching at 1 at infinity, and this will be touching at 0 at minus infinity. Okay, so this kind of curve is there. So you can see basically what I am going to say, this curve is bounded in 0 and 1 only. And what is the value of 0 1? We know that 0 1 value is probability also there is, which also gives us the value in between 0 and 1. So basically what sigmoid curves give, sigmoid curve or sigmoid function, if you pass this y value into this sigmoid function, it will give us any value which is between 0 and 1, and which will represent the probability. Okay, and now how to estimate it, how to estimate y value, because y value is either taking 0 or taking 1. But here fy function, it will give you some value in between 0 1, that is some floating point value. Let us suppose it is 0.08 or 0.8 or 0.5, 0.1, like this. Okay, but these values are not 0 1 value. So how to how we can convert these values to 0 1? We need to consider a threshold. A threshold, and this threshold is basically is 0.5. If this value is greater than 0.5, then we will consider it as 1, or we will consider as 0. So now 0.08, simply it is not greater than 0.5, so we will consider it as 0. Second point is 0.8, it is 1 as it is more than 0.5. 0.5, now 0.5 we can consider either 0 or 1. Let us suppose it is 1, 0.1, it is 0, and so on. Okay, so this is basically the uh, logistic, the process of logistic regression. Now how to implement it, it in MATLAB. So directly you need to code it. Basically directly you cannot use this program in MATLAB. Yes, MATLAB can identify these values, these probability values hardly. Okay, MATLAB can estimate this function, MATLAB can estimate the sigmoid function also, the values of the sigmoid function, the probability values MATLAB can give you, but MATLAB cannot convert these probability values to 0 and 1. Okay, so these probability values you have to convert it using some simple coding. Just you can use a for loop or some other loop, and if the value is greater than 0.5, then it is 1, otherwise it is 0. Okay, so let me give you an example for this in MATLAB. So this one, and let me go to the data set, and let me, so here we use column vector. That is, I want to means um, that I want to take each and every column as a different vector. Okay, as a different column in MATLAB. There is the blood pressure. Blood pressure, I want to store the blood pressure values, that is 114, 118, 112, and so on, as a separate vector. That is why I have used, I am selecting the column vector. And let us import. After importing that, you can see all the column vectors are selected here. Now let's go to MATLAB. So you can see here, go to workspace, and you can see the blood pressure range. You can click. Okay, you can see that each and everywhere NaN value is created, as because this is also my mistake, means I have selected the for previous means there is a null value in the first column by mistake, so that is why it is showing like this. No issue, MATLAB can automatically handle it. So our first one is x1, second one is x2. So what I have selected now? Did I select the all means parameters here? I have selected the parameters: blood pressure range, okay, nutrition, that is diet and nutrition, normal 1 and abnormal 0, ECG report, heart rate range, medication, physical activity, PPG signal range, and sleep pattern. Okay, so x1 to x8, I have created 8 means variables x1 to 8, x8, and I have stored the blood pressure range, the values in x1, the diet and nutrition in x2, and so on. And our, you know that according to the dataset, symptom of paralysis, which is either 0 or 1, I have stored it in y. Okay, now I have created another matrix, capital X matrix, for all these x1 to x8 values. Okay, let me show that how this capital X matrix looks like. So let me show the capital X. Oh, I'm sorry, it was first I need to run this. Yes, now capital X, you can see, since the space is small, so that is why. Look. So column 1 to column 7, the values are written here. Okay, and the rest column 8 to and column 8, this is the column 8, this one. Okay, so it is looking like just a matrix with the number of rows and 1001 rows and 8 columns. Okay, and y is symptom of, there is a y is a single column here, which is the symptom of paralysis. Okay, now what we do here, always remember that if any kind of, whether you are using MATLAB or whether you are using some other software, you are using Python or Jupyter notebook or whatever, any case, all the cases, the categorical variable, you need to convert it to numbering format. That is, If it is binary, only yes and no is written there. So you need to category means convert them to any numeric form like 0 and 1. If there are three different categories there, let us suppose you are estimating the model of the car, and the outcome variable is containing three different models, like means Toyota, Tata, and another companies, let us suppose Mahindra. So three different companies are there, so three categories, so we need to number them as 1, 2, and 3, and accordingly you need to arrange without converting to the number format. You cannot, no program or nothing can uh, you can run. Okay, so that is why the ycat is another variable. I have what I have created here. What I did, I have used the categorical command in MATLAB. What categorical command do? Since y symptom of paralysis, it is only it is a categorical value. So I need to first convert these values to categorical value, and you have to use this command in MATLAB. And specifically, I am saying in MATLAB to run this any kind of categorical data set. You have to use it. Next is our command mnrfit. Mnrfit will not give you the probability. Mnrfit basically will give you the model. Which model? This linear model. You can see y equal to a naught plus a1 x1. This linear model, there is a value of y you can get. Okay, so let me, if I run this, and let me show you what is mnrfit. So mnrfit is actually represented by mdl. So let me, mdl, look at this. Okay, let me analyze the first one. It is the intercept, that is the means uh, constant. Second one, this is the coefficient of the first variable, that is blood pressure, that is the minus 0.0244 into blood pressure. Next coefficient is 0.1595. So this is the coefficient of diet and nutrition. 0.1595 into diet and nutrition means x2. Similarly, this one into x3, into x4, and so on. So the model is created by mnrfit command. Okay, now how to convert this model? Now I need to pass this mdl values to that sigmoid curve. So for to pass that sigmoid curve, we need to use mnrval. This is after passing the sigmoid curve, mnrval, this command will give you the probability value, and which is, I have used another variable y predict. So y predict equal to mnrval mdlx. Okay, so let us means y predict. Let me show you what is the value of y predict. Look at this. Basically, there are two. Since my MATLAB is it is the version of 2014, so that is why it is showing that two different columns. Otherwise, the new version of MATLAB, it will be that it will show only one column there. So basically, you need to means use the first column. Okay, the first one. So first one, it is, look at the first probability, that is 0.9045. Second one 0.8706. Third one 0.9011, and so on. Okay, don't look at the second column. Second column is the 1 minus the probability. It means that 1 minus the first column, it will give you the second value, which we don't require right now. Okay, so now for the prediction. Now I already told you, so let me I have created another ZP just to show the first column. So let me show the ZP only. Yes, this is only the probability of the first column. That is the original probabilities after passing the variable into that function. okay, sigmoid function. Okay, now what we need to create. So I already told you, since 0.9045 it is more than 0.5, so we need to convert it to 1, right? 8 7, this is also 1, okay, and so on. So now that is why I have created another program here, that is C equal to another vector, that is in MATLAB we can create a vector like this, okay, which is a null vector. So for I equal to 1 to 1000 and this and this, and after that it will automatically create this one, okay. So how to show that one, how to show? So we need to show this by, let me again, X regression, okay, control C. Oh, I'm sorry, this is same values actually. Yes. So all the rows you can see, the column 1 to column 7, so these are the values. Column 8 to 14, this is the values. So 15 to 25, so all 1000 columns you can see, all the estimations are shown here. But this is a very large, we don't actually require here, we need the error, okay, right? So how to do this? We can do it by plotting this. Oh, sorry, there is some. Okay, you can see this one. This is a plot function. This plot is actually the plotting of the means probability. Okay, you can see if you plot the probability, it will be also, it is showing like the means values of means sigmoid. That is the sigmoid curve you can see here. So it is basically, you can see these the estimated values here. Okay, so y predict 01 here, the this one y predict 01, it is only the estimated values you can see here, okay, in terms of the probability only. Okay, you can see that this is not only 0 and 1 values, there are different values and shown in different forms. So the curves are like this, it is a looking like a noise, right? So this is how you can create the model, okay, in logistic regression. Okay, there are some other many other things we need to means discuss about this logistic regression, and what is the accuracy of this logistic regression, and what are the different metrics to find out the accuracy of this model in classification model. As I told you that there are different metrics we use in classification model and in regression model. In regression model, the metrics are R square values. Okay, the values of means root mean square and mean square error. These were the values. But here in classification, the metrics are different. One is confusion matrix. First, we need to get the confusion matrix. F1 score is there, okay, and type 1, type 2 errors are there. So different metrics are there, which today I have no, I do not have the opportunity to discuss all these things because there is a large discussion. Okay, so this is a idea of logistic regression for today. So this is the end of the session. Now, if you want to ask me any question, you can ask me.
Yes, sir. Thank you so much, sir. And we have few questions with us. And the first question is that, as you have mentioned, I guess there are some
Can you please
technical difficulties.
copy and paste it in here, because your voice is not audible at all.
All right, sir. I will do that.
Yeah.
So the first question that we have: do softwares and its version respond differently?
to softwares.
Yeah.
Can you please repeat it?
So do softwares and its version respond differently?
Yes, yes, yes. Software and this version can respond differently because these models are actually basically in logistic regression. If there is a fixed model you can use, that is, I have used a model in linear or non-linear regression, or in logistic regression also we are using a particular mathematical model is created. If you create a model, then the model values will be same for different softwares also. But in case of ANN, where no mathematical model is created like that, okay, you can have not only not different softwares, for each and every run you will be having different values also.
Right.
Which
So
MATLAB version is the
yeah.
best for signal processing? Basically, MATLAB version is, if you use higher version of MATLAB, that also you'll be getting the higher advantage for that. Okay, so signal processing in MATLAB there is separate toolbox. Is if you're using the higher version of the MATLAB, the toolbox you can have many other features or new features are there. Okay, so of course the better version will give you the better opportunity. How to implement GA? GA is a different thing. This GA is a genetic algorithms, which is an optimization toolbox. Okay, and it is also a meta heuristic approach to get the optimization values of any function. So optimization modeling is entirely different thing. Okay, so GA is an algorithm for the optimization modeling. We cannot this is regression or classification, it is totally different thing. Optimization is totally different thing. Okay, you should not match both of them. Okay, GA toolbox is available in MATLAB. Okay, GA toolbox is also you can use different means in script also you can use GA functions, or a separate toolbox or user interface is also available in MATLAB. You can just put the function. If you have any constraint, you can use the constraint, and you can call the GA function. GA will give you the optimal values.
Okay. So thank you so much for clarifying all those doubts of our audience. And I hope that everyone has gotten wonderful insights and takeaway about AI and ML, that how we can utilize in real time application. And today, as you have mentioned about the wind energy, how they use a machine learning in order to design and wind turbines. There are different types of turbines. So, thank you, sir, for giving a wonderful hands-on sessions. And you have given the way that how to modulate and how to program and code it and how to get in result, and also how to find out the error analysis. And thank you for wonderful insights, and I hope our audience have equally enjoyed and learned the lesson from us. So thank you once again to our audience and also to our experts. So as again I would like to thank all our experts that has been conducting from for last week onwards. We are conducting 7th November to 11th of 12th of November. And so I hope you are also interested and you are also eagerly participated. So thanks to you as well for also to support InnovaWorld, and you are following InnovaWorld Research Center. And I hope all of you should submit your feedback link. Feedback link is live in the chat box, and hope all are submitting their feedback link, feedback form, so that you can achieve your certificate. And it's a request to our those who are new to our InnovaWorld session. Make sure of that you will get your certificate in this website, which is innovaworld.in/updates. So here is a box like skill development certificates. So after a week, you can go and access the skill development certificates from here. So if you open it, so you will get a drive link. So you just find your name and all the details over there. If you have any other issues in that, you can directly contact us. So that won't be an issue for that. So after a week, you can go and visit and download your certificate, a week certificate. And the certificates will be given to those who are only taking part in these sessions. And very shortly in the next month, we are coming up with a research article writing. So again, it's an FDP program for especially for the faculties and the scholars. So we are expecting your valuable participations and enthusiasm to to learn more about that how to write like strategies to how to publish research articles and how to write. And there are again hands-on activities will be there, that is around 10 days workshop and development skill development program for the faculties, you can say. So hope you're enjoying with us, enjoying with Innova World Research Center. So good night, everyone. And once again, before leaving the session, don't forget to, you know, fill up the feedback form. So again, good night, everyone. Stay blessed. Thank you so much again. Thank you, sir, for your valuable time, sir.
Thank you very much.
Yeah, thank you, sir.